The short title, or the other title, or alternative title, is the Physics for Skeptics. I'm going to be talking about energy, I'm going to be talking about quantum mechanics, and thermodynamics. And I'm pulling an argument from authority.
Why is your name smaller than your credentials?
Because no one cares about the name. It's that PhD, that piled higher and deeper crap.
All I see is the BS.
Is that what we should call you?
So, for the quantum mechanics part and for the thermodynamics part, I'm going to be talking about these in the context of certain specific pseudosciences that are out there. But to start off with energy, I'm really going to be talking about what the heck is energy.
I, for one, would love to know.
We were having this debate in the back row. The very broad physics definition of energy is the ability to do work. I mean, it's really quite simple. It is, you can put in a few extra words, it's the ability or capacity of a physical system to do work, or the ability to exert a push or pull against basic forces of nature along a path of a certain length. But that is, yes it is. This is according to 3 college physics textbooks. And Wikipedia. So, you can, I can bring in the textbooks if you'd like.
Sorry, I have to leave. Go ahead.
My point in this, and you could argue and quibble about maybe the small details of this, my point is what Desert File was saying, that physics, the definition of energy is not consciousness. It is not an amorphous blob of consciousness. And as we were going through the past few talks, I was quite ticked that everyone was using slides that I was planning. So I also used the Star Trek energy being, thankfully, a different Star Trek energy being.
With reference.
Yes, I reference.
Yes.
I'm a scientist, I have to reference things. Yes, you'll notice that a lot of pseudoscientists don't reference things. That should be a key thing that you look for. It's not mind power. Energy is not organized structure. Energy is not ghosts. Energy is not magic. Energy is a specifically defined physical quantity. It has a specific word definition. It has a specific mathematical definition. It's not whatever the hell you want it to be. If you're more interested in energy and what it is not, I highly recommend Skeptoid episode number 1 on New Age energy. So now that you have a very basic idea of what energy is and what energy is not, we're going to go into quantum mechanics. And I'm going to talk about quantum mechanics applied specifically to ESP and homeopathy. So this is sort of the wrap-up talk. Unintended, but it turned out that way. Quantum mechanics has a few basic tenets. There are actually a lot of them. I'm going to address 2 because those are the 2 important ones, and I doubt anyone here, maybe 1 or 2 people are physicists or have a physics background. Raise your hand.
Physics background.
Okay. So you have to rely on me with that PhD. Dad, you can go out in the hall. So one of the basic tenets of quantum mechanics is that particles exist as a probability function until they are observed. And we should also point out that by particle, I mean something that is very, very small. So if I were a particle, I am not. I'm composed of many particles. But if I were a single particle and you are not all observing me, I would not actually be here. There would be a certain probability that I'm here, but there would also be a lesser probability that I'm over here, or that I'm over here. Here, a little bit higher probability, but right here is where the greatest probability is. Probably. I'm observed, then we know where I am. I am here. Now, we can't actually know exactly where I am. That gets into the Heisenberg uncertainty principle, which I'm not going to go over, but based on the timing of this talk, I think that there will be time at the end for questions. So you can ask about that if you're interested. The way this is demonstrated by this photograph, or this image that I found, is that These are electron configurations around a hydrogen atom, where what you're looking at is the probability of the electron being in that location for different energy states. This is the most basic, this is the lowest energy state. Now, it's most likely that the electron will be found here, less likely out here, but until that electron is actually observed, it exists as a probability wave, and we don't actually know where it is. And tests have shown that it doesn't know where it is. It might be there, it might be here. So this is one of those weird things about probability and about quantum mechanics that led Einstein to say, God doesn't play dice with the universe, or some semblance of that quote.
You haven't seen the end of Men in Black, then?
I have. I wish I hadn't. The other main tenet of quantum mechanics, and this is where we get the term quantum, is that energy is quantized. It is discrete amounts. It increases and decreases a certain amount, and you can't have a continuous spectrum. So you can be either at the ground state, you can be at the first level state, the second energy, the third, the fourth, and so on, but you cannot be at the half energy state, or the 3/4, or the 1 1/3. There is no ramp up of energy. It is quantized. Fortunately, in my quantum mechanics class, our grades were also quantized. We got an F or an A. There are some consequences of quantum mechanics. One of the consequences of quantum mechanics is that we can't know the state of something until it is observed. And that observation also affects that end state. This is epitomized by the famous Schrodinger's cat thought experiment. Schrodinger did not actually do this with a cat. The idea behind Schrodinger's cat is that you have a box that is completely sealed off from external viewing. You can't know what is going on inside that box unless you open it. In that box, you stick a cat. They decided to stick Schrodinger's cat in because Schrodinger is probably considered the father of quantum mechanics. The main equation in quantum mechanics is Schrodinger's equation. So you stick a cat in the box, and you also stick in a radioactive isotope that will decay and emit a poison. And that decays due to specific quantum mechanical probabilities. So at any given time that that cat is in there, it could be alive because it hasn't inhaled enough poison, because there hasn't been enough given off, or it could be dead. We don't know. And so it can actually be thought of as the cat being both alive and dead. And I don't know the details of the experiments, but this has actually been shown to be true, that the cat would be both alive and dead at the same time. When you open the box, however, you collapse that probability function, and it is either alive or dead. Or the cat can stick a person in the box. The second tenet or consequence of quantum mechanics that I want to discuss today is that of quantum entanglement, and that's because this is how the ESP and the homeopathy claim that quantum mechanics works. Quantum entanglement is a complicated idea, but I tried to boil it down to 5 basic steps. The first idea, or the first step, is that two particles, so two small things, are created from an initial particle. They're part of the same quantum system, and that's important because there are conservation rules, because they were created from the same initial particle, that states that they cannot have the same properties. So one thing in quantum mechanics that we talked about is that particles can have a spin up or a spin down. In notation, we just write that as an up arrow or a down arrow. So one of these particles has to be spin up, and one of them has to be spin down. But we don't know which is spin up and spin down until they are observed. And with the Schrodinger's cat situation that I just discussed, they are actually a superposition of both at the same time until they are observed. So both of these particles that were created, that are entangled in the same system, are both spin up and spin down at the same time. Then we can separate them, and then we can observe one of them. And when we observe one of them, we observe it to be either spin up or spin down. The instant, and I do mean instant, that we know that that one that we observed is spin up or down, the probability function of the other one collapses as well, and it's the opposite. And I say instant because this is actually faster than the speed of light, and this has actually been so this is one of the reasons why both quantum mechanics and general relativity are incomplete physics systems, because they don't actually mesh with each other. General relativity says that you can't travel faster than the speed of light, but this happens faster than the speed of light. So this is another weird thing of quantum mechanics that just doesn't seem to make sense. And if you do understand it, that means that you don't understand it. That was also the first thing that we learned in quantum mechanics when I sat down for a year of it in junior college was, the professor stood up and said, if you get to a point where you say that you understand quantum mechanics, then you don't.
Since we're along those lines, I've always wondered this, like, I clearly don't understand quantum mechanics, but I have sort of an idea of what it's about based on talks like this. But when you go and get a PhD and you study all the math behind it, learn all the equations and stuff, is it actually, do you get closer to a feeling of understanding, or does it get like more?
For me, no. I took it because I had to take it for my degree.
Gets worse.
I mean, my undergraduate degree was astronomy, and I had to take the entire physics core just without the lab classes. And so I had to take a full year of quantum mechanics, and I just went through the math, and I generally sort of got the concepts, and the math was just like, okay, you put this equation in here, put this thing, and that was it. So I am not the person to ask detailed questions about quantum mechanics of, but I have enough background that I can give you the gist of what's going on. If I were a quantum mechanic, and I think that would be an awesome name for an auto shop, and if you want us the best, the quantum mechanic.
And it's not.
Drive it, and let us know if it's fixed or not. Right, and so if I were a quantum mechanic, or a quantum physicist, then I would have understood it better. I am not, therefore I don't. The final thing that I wanted to point out here is that, again, these apply to very, very, very tiny things. Not homeopathic type illusions, but very small things, like atoms and subatomic particles. You can get up to molecules, but once you get past molecules, then you are no longer dealing with a quantum mechanical system. The probability functions all collapse into the classical system that we know from basic Newtonian physics. And that's really what we get into when we talk about ESP. The claim goes that human brains are quantumly entangled, and so they can transmit information from each other faster than the speed of light, or just they can transmit information to each other. I have heard this claim by several alleged psychics. The rebuttal to this is, again, quantum mechanics applies to atomic scales. Once you get to the level of brains, and even Homer's brain, you're in a classical system, and quantum mechanical effects are no longer relevant. Also, quantum entanglement is a very fragile state for these particles to exist in, and they're very easily disturbed and will break out of that single quantum entangled state. Third entanglement has only been shown to exist from two individual particles, so Homer v. Homer. Not an alleged psychic who then can implant an entangled particle in your brain and figure out what's going on and connected to everyone else on the world. It is two particles. Yes.
From a quick reduction standpoint, is it the summation, I don't understand, is the summation of all the quantum effects lead to the effects that we observe that are the traditional Newtonian mechanics in physics?
Basically, yes.
Okay.
Basically, because you're dealing with these probability functions, and once you add enough together, you just get this spike. So that's the physics. Another one is just sort of what we go to as skeptics of no mechanism has ever actually been proposed whereby a brain can read this supposedly entangled information. Now, mechanism is not necessary, but it just sort of adds to this other stuff of make a claim, but if you have nothing backing it, then what's the point, other than to make money? So next we have homeopathy. Again, I saw the last talk and the person was not happy. Apparently someone else uses Google image search. This is the first image that you get when you search for homeopathy.
And you both liked it.
And I did. Well, I needed a white background. So, so the claim goes, and I'll go through this quickly, is that homeopathy changes the quantum state of water and entangles it with the material. So, like caffeine for the sleeping pills. So even if there's nothing left of that original material, the water is imprinted with that energy. So now there's a lot in there, and this is just one of the gajillion different supposed ways that homeopathy works, which it doesn't. If that wasn't clear in the last talk, homeopathy